so again, reviewing what we did 2 classes ago. So we have just a little chart here dealing with exponents, writing it out with words, expanding it, and then finding what the actual value is. And then we have an absolute value, and we have a cube root. All right, so taking a look at our first one, here we have this guy. What is this in words? Alexis, what is this in words? Very good. 8 to the second power. What else could we say instead of 8 to the second power? 8. Good. So either one works. I'm going to go ahead and write squared since it's just 2 words then, and rather than.
And I have a trick to you that one of my part 1 kids told me. So remember the difference between squared and cubed. A cube looks like this. Well, this is a square, and this is a cube. I'm really bad at drawing. This is 2D, this is 3D. So like 3D movies. 2D, 3D. Cubed is 3D, so it's to the third. Square is 2D, it's to the second. Okay? If you need to write that down, write it down.
That is 2D, 3D. That tells you your power. Cubed and squared. Square is just with a 2, cubed is with a 3. Alright, and expanding this out. How do we expand it? Using multiplication rather than exponents. Trey, how do we go about doing that? How would we write this out expanded instead of using an exponent using multiplication? What is 8 for the same thing as? Very good, 8 times 8. And what does 8 times 8 give us? Wonderful, 64. Alright, so that's the format that we're going to be following for this chart here. Once you kind of see that, and then it's not too bad. So here it says 3 to the 4th. Naaman, what's that going to be in exponential form?
3 to the 4th?
Yeah, 3 to 4. So which one's my base? 3. Very good. That's my larger number. And then what is my exponent going to be? Very good. So 3 to the 4th. And ooh, how do I write this in expanded form?
3 times 3 times 3.
Good. 3 times 3 times 3 times 3. Anybody know what that is? 81. Morgan? Sorry. Good. 81. 3 times 3 is 9. 9 times 9 is 81. Okay. How about our next guy? David. What is this guy? In words. How do I say that? Very good. 2 to the 7. A little bit more words. 7. And everyone, how are we going to write this out? 2. Everyone means everyone. Times 2, times 2, times 2, 7 times, right? 1, 2, 3, 4, 5, 6, 7. Oops, I can see by the end. Alright, what's 2 to the 7? 128? Thank you, Hector. Sorry. Thank you, Hector. Okay, our last one. How do we go about doing this one? What does that give us? How do we say that? Almond, an idea?
A number to the third.
Very good. A number to the third. What's another way we can say it? A number cubed, right? Remember, to the third power is cubed. So a number cubed. I'm going to use that one just because it's fewer words. And we write this as x times x times x. Now we don't know the actual value of x, so we can't give a numerical value here. Numerical meaning a number. I can't give an actual number here. So it's just x cubed. Right. Any questions on that? Alright. Letter B. What is this symbol here called? Absolute value. And what does the absolute value do for us? Mohammed? Exactly. It tells us the distance from 0, so we just take that number and make it positive. But this one's kind of tricky. So if I look at just the absolute value by itself, just this guy, what is the absolute value of negative 2? 2. So I know that this is 2. But we want opposite of that. So this itself is just 2, but that negative in front means our final answer, negative 2. Alright. Questions on the chart or letter B? Alright. And Joe, do you remember what this symbol here is called? Do you remember what just this guy's called? You're on the right track. This 3 here does mean that it's going to be a cube root rather than a square root. So, Tayshawn, since you seem so confident over there, what is just this symbol called? It is a square root, but what is this actual symbol itself? It starts with an R. It's what people used in the 70s to describe something cool.
Radical.
Radical, yeah. Or
Totally
grouping,
rad,
but this is a
dude.
radical.
That's more surfer dude.
That's long before your guys' time. Alright, so this is a radical, and if there's no number in front, that's square root. But here we have a 3, and as Joe said, that's going to be a cube root. Where do we find a cube root in our calculator? What button do we have to hit?
Math.
Math. Thank you, Abdul. Math is the button we have to hit for that, and that's important. Tayshawn, what did I just say? Very good. Math is the button we want to hit for our cube root. So we take the cube root of 169. What do we get? I think it's a decimal. 5.2. Give me the next one. 5.52. All right. So make sure you check the directions for knowing what's correct. Any questions on this? Alrighty. So let's take a look at the homework then. Do we have any questions on numbers 1 through 9? Give you a few seconds to take a look at it. Questions on 1 through 9? What was the acronym we learned last class to tell us which order we need to do our operations in? Very good, GEMDOS.
I forgot that's not a smart word.
Alright, so we have GEMDOS, and you'll hear that also referred to as PEMDOS. Right? What does the G stand for? Grouping. And what type of symbols tell us that it's being grouped together? Parentheses, very good, that's where the P comes from. We might also see square bracket. What other type of grouping things do we have? Absolute value, very good. Fajr, did you have another? Okay. There's one more. There is that weird looking one. Yes, there's curly braces. Those are difficult to draw. We probably won't use them as much. There's another one besides that. We just talked about it. Yes, very good, radical.
Also, if I have a fraction, its numerator and denominator are off the left. What is its numerator and denominator? What do I put around their numerator and denominator? Good. That would be a what?
Right, so when we have a fraction, we need to make sure we simplify the numerator and then simplify the denominator individually.
If there's only one number on top or bottom, we don't have to worry about it. But if there's more than one number, we have to deal with that.
Okay, what does the E stand for? Exponents, very good. And we usually see that with parentheses squared, but sometimes it's just a number by itself squared. Alright, so we go grouping, then we go exponents. Then M and D come together in a pair. What do M and D stand for? Multiplication and division. And we just go from left to right. Alright, so start on the left side, move to the right. And then finally, AX, what comes after multiplication and division? Addition and subtraction. And again, we go from left to right. Okay, so that's what we were working on last night with their homework. Just to recap that. And if we don't have any questions on 1 through 9, we still don't have questions? Good. Okay. About 7 through 11, any questions on these? This is where we had to evaluate. Yes?
Why aren't we simplifying fractions?
such as which one? Like reducing 4/3? You can't reduce it any more than that. You could say 1 1/3. That would be fine as well. Yeah, 1 1/3 is totally fine. If you, that's what we call a mixed fraction. This one here is called an improper fraction. You can have either one, and they'll be perfectly fine.
Please do remember, guys, that if it starts in a fraction, you need to end in a fraction. So you should not be writing a decimal for number 7.
That is very important. If we are starting fractions, we want our answers in fractions. I recognize here these are decimals. If you convert those to fractions, that's fine. But if you if you start with fractions, though, we should end with fractions.
And honestly, unless it says you're dealing with money or it tells you to round to a decimal place, you should almost always have a fraction.
I prefer fractions.
Yes. And the
Because
other
it's an
one is
exact value.
you don't round with fractions.
Any questions on 7 through 11? Okay. How about 13 through 16? Any questions on these? Double check your answers. Any questions? We're good? Okay.
Taking your quiz, now it's the last one to ask.
Wait. Okay. Number 15? Okay. Number 15. Let me. We haven't gotten to the bottom yet. I just need to see the problem right now. Thank you. Okay. Number 15, you said? Alright, number 15, we have 3 plus x minus the quantity. Notice I said the quantity when I'm using any type of parentheses. Negative 2 plus the quantity, negative 7 minus y, and quantity squared. When x equals 1/2 and y equals negative 6. Okay, so we are supposed to evaluate this. Normally, if we didn't have our numbers here for our variables, we would have no idea what the value actually is, because these variables could represent anything. Well, then someone comes along, hey, x is now going to equal 1/2 and y is now going to equal negative 6. We say, great, let me tell you what the entire expression, this here is an expression, means. Okay, so we're going to take our x value and substitute in for x anywhere we see an x. If I had an x somewhere else, I'd also substitute it in there. Likewise with my y value. I'm going to take this and substitute it in for y, anywhere you see y. Alright, so let's rewrite our equation now. Inserting these values into our variables. So it's 3 plus, instead of x, I have 1/2 minus square bracket, negative 2, plus negative 7 minus, instead of y, I have negative 6. Make sure you don't lose that negative there. Okay, so again, I have my y value here, and my x value here. So just substitute it. So now we just follow Gen Bell's order of operations. Alright, and we see we have more than one set of parentheses. So we just work from the inside out. So I'm going to start, okay, inside out. Alright, so we have negative 7 minus a negative 6. Minus a negative, same thing as Anyone? Plus a positive. Okay, plus a positive. I want everyone to look at me. I want to see a big smile on your face. And I want you to go. Okay, no one did the breath. I want everyone to go. Okay, we are awake. We are in math class. We're going to get to work. I want some answers. And I know a lot of your names now, so be ready to give a response. So we have -7 plus a +6. What does that give us? -7 plus +6.
-1.
Thank you! -1. Okay, so let's go ahead and fill in the rest of our information here. So I have 3 plus 1/2 minus -2 plus, instead of this entire quantity here, we have just -1 squared. Okay, let's go ahead and still simplify what's inside our parentheses. -2 plus -1 gives us? Good, -3. Thank you, Naman. Let's go ahead and combine this together. What's 3 plus 1/2? Oh, that's a fraction. Maybe we'll leave it for the end. Alright, -3 squared. If you want. -3 squared, you know that one. What's -3 times -3? What's 3 times 3? What's 1 times 3? Put it in your calculator. -3 times -3. Good! +9! Remember, that negative must be included in your parentheses when you square. So 3 plus 1/2 minus a +9. Alright, so now we're just going to do addition and subtraction. At this point, you could go ahead and put this into your calculator. I'm going to do it by hand. So we have 3 plus 1/2. 3 is the same thing as 6/2, so you have to have common denominators to add it together. Again, you can just use your calculator for this. And 9 is the same thing as 18/2. So 6/2 plus 1/2 would be 7/2 minus 18/2. And you should get your final answer to be -11/2, which is -5.5. Can we get that? So that's your final value. That answers your question on. Alright, other questions on the homework? Sorry, Mohammed. Okay, taking a look at those bottom 6 questions where you had it in boxes. Any questions on those? I'll switch to the screen here in a minute. Those bottom 6 questions. I'm going to show the answers real quick so you can check. Then I'll go back to my other screen. 17 was 21, 18 was D, 19 B, and you had to evaluate filling in these boxes. Any questions on these problems? Are we good on these last ones? The last class had some questions on it. I need to see that. Remember, we do have a quiz right away. Okay. Take note for number 18 that you need to substitute this value in for both x's. You fill it in for every single x. And then remember for your charts, you're just simply taking these x values here and taking each individual one, so -2, substitute that in for my x values, find your y value, and then repeat for each x value. Substitute it in, find your y value. Okay? Here's that if you're still writing it down. Alright, if there are no more questions, any last questions before we take the quizzes? Go ahead and put away your materials. Leave out your calculator, pencil. We'll pass out the quizzes.
Everything should be away, please. When you finish with your quiz, you may bring it back to the table back there next to my desk. Like last time.
Where you at?
Grab your quiz before it falls.
You got some bad shit doing with me. Got some bad
Should
shit.
I grab your quiz before it falls?
The class are longer. Yes,
Alright, quizzes are out. Please be quiet.
You got two.
When you have finished your quiz, I want you to go ahead and do the multiplication review, numbers 1, 2, and 3. And I want you to take a look at what it says beneath it about the distributive property. And see if you can do numbers 1, 2, and 3 below that. Alright, let's go and take a look at the quick multiplication review. This is something that you should be able to do like that. Alright, so we have 4n divided by negative 2. What do we get for our answer for this? What I think. Alright, what do we get for our answer for number 1? You want to give it a try? Joe, what'd you get for that? Okay, what'd you get, Sarah? So did we have negative 2?
Told you.
And what else do we still have with it? N, right, negative 2n.
Told you.
Remember, we simplify the coefficients. We're simplifying our coefficients here. So we have 4 divided by negative 2, which is negative 2. The n is not divided by anything, so it's just n. Alright, but how about our next one, number 2? What do we get for negative 4x times 5x? Just give it a shot. What's negative 4 times 5?
Negative 20.
Very good, negative 20. Who knows what we do with x times x, Joe? Yeah, it's x squared. Very good. Alright, so remember when we have the variable multiplied by it's the same variable, we are adding our exponents together. So 1 plus 1, which is 2. X times x is x squared. Good. Right, so then carrying that information over for number 3. Anybody want to give that a try? What do you got for number 3? Trey, what'd you get for your number? What's -7 times 3? Good, -21. Alright, K1, what is x times x? Or sorry, what if we have xy times y? What does that give us? We have xy times y. When we multiply those together, what does that give us? Let's
Wait.
break it up. So I have x times y times y. There's no other x to combine this with, so we still have our x. What is y times y? So we just were talking about. What's y times y? What is x times x? X is x squared. So what's y times y? Y squared. Alright, so we have then x, y squared. Again, you multiply together the variables. So x, there's no other x to combine it with, so we have just x. And y times y is y squared. So our coefficients multiply together, our variables multiply together, each one multiplied with another one that's like. Questions on 1, 2, and 3. This should be straight review. If you did not know how to do these, you need to come see us so that we can give you some extra practice. That is material you should know before coming here. Alright. So let's take a look at something new, something called the distributive property. Has anybody done this before in a previous math class? Okay, good. So distributive property means that we have a set of parentheses. Sometimes you might see that square bracket. And so what we have is a number, so we have here A, times an entire quantity, E plus C. And that quantity means we have parentheses. So when we are distributing, when we encounter this situation, what we have to do is distribute this A to both the B and distribute it to the C. So I have A times both B and C. So A times B and A times C. You can think of it as if I had, let's say, a bunch of cookies, and I gave one to each person. I'm distributing my cookies out. That means each person is going to get that cookie. It's the same thing here. Each term within my parentheses is going to be multiplied by that number in front. And it can look in different ways. It's not always going to have a plus sign. It might have a minus sign, as we see here. And you still treat it the same way. And also, the number that's being multiplied, A times quantity plus C, it might be written after our parentheses. So we might have to distribute them this way. Same idea, we are still distributing the A to both pieces. And then again here, A times B minus A times C. And then again here, A times B minus A times C. Alright, so taking a look at some actual examples. Here I have 2 times the quantity x plus 5. That means I have to do 2 times x, that's a piece there, plus 2 times 5. Right? And 2 times x is 2x, plus, and 2 times 5 is 10. You don't have to write this stuff in between. You can go ahead and go straight to your answer here. If you can do that in your head. 2x, and then 2 times 5 is 10. So this is your final answer here. The common mistake people make with this is they will forget to distribute it to that last piece. This is what I see all the time. 2x plus 5. These are not equal. Make sure you distribute your 2 to both pieces. Questions on that? So again, with these other examples here, I have to distribute my 8 to the 1, so I have 1 times 8. And my 8 to the n, so n times 8. And then again here, 3 times 1, which is 3, minus 3 times 4y, so minus 4y. So again, distributing that term in front to both pieces within your parentheses. So let's go and try a couple of these. So number 1, we have 5 times the quantity n plus 3. So again, I'm going to distribute my 5. So I get 5 times n, which is 5n, plus distribute the 5 to the 3. 5 times 3, which is 15. Very good. Now, when you've gotten your answer here, double check to make sure, see if you can combine any like terms. Here, there's nothing to combine, so this is our final answer. Alright, let's take a look at number 2. I'm going to have to distribute my 3 to the 2p. Alright, so 3 times 2p plus, distribute my 3 to the 6. 3 times 6. What does 3 times 2p give us? Very good, 6p. We multiply just our numbers together here. So 6p plus, and 3 times 6? 18, very good. Like I said, we're going to work on those multiplication facts because we want to know it right away. Alright, so 6p plus 18, and that's our final answer. Alright, any questions on that? Alright, let's go and take a look at number 4, and we'll do number 6. Alright, so number 4, now we're throwing some fractions at you. Same idea. We have to distribute my 2/3 to the 3x. So I have 2/3 times 3x. And then distribute my 2/3 to the 9. So minus 2/3 times 9. So again, I'm distributing that 2/3 to both pieces. I'm distributing it to both terms within my parentheses. 3x is a term and 9 is a term. A term is a mixture of multiplication with letters and numbers. You might have just a number, you might have both, you might have just a variable. Alright, so let's go ahead and multiply this out. We can do this one by hand pretty easily. Remember, 3x, same thing as 3x over 1. When we multiply fractions, we multiply straight across. So we have 6, 2 times 3 is 6x over 3. And 2 times 9 is 18 over 3. And let's go and simplify. 6 divided by 3 is 2x. And 18 divided by 3 is 6. So 2x minus 6 is our final answer. If you struggle with those fractions, you can use your calculator to help check your work. Make sure you put it in parentheses though. And in your calculator, you can't do the variable x, so you would just multiply 2/3 times 3 to get your coefficient in front. Coefficient is that number in front of your variable. Coefficient there. It's important to understand these terms. Coefficient is your number in front of your variable. Questions on that one? Okay. So let's take a look at number 6. We have multiplication here, and notice the distributive property is only for when we have multiplication. Notice each of these are multiplying. If I had 2 plus the quantity 3 minus 5, I'm not distributing my 2 because this is addition here. The distributive property is only for multiplication. This here is saying I'm going to add 2 plus whatever this value is. So this would be 2 plus 3 minus 5, negative 2, which ends up being 0. Notice the difference between that and this. Let's say x minus 5. So I'm multiplying here, and that would be 2x minus 10. So notice the difference. Multiplication is when we can distribute. Addition or subtraction, we're just simply adding and subtracting whatever that simplifies it. Alright, so let's take a look at number 6. So I'm multiplying the quantity y minus 5 times negative 4. Make sure you don't lose that negative. We're going to have to distribute my negative 4 to the y. So negative 4y. And then distribute my negative 4 to the 5. So minus, what is negative 4 times 5? What is 4 times 5? Good, 20. So if I have a negative, and that if I only have one negative, negative times a positive is a negative. So my answer is negative 20. Right, so minus a negative 20. But remember, minus a negative turns into a plus a positive. So this is just negative 4y plus 20. You could have also thought to yourself here, negative 4 times negative 5 is positive 20. Add your positive. Okay, any questions on that? Let's take a look at let's go with number 9. So sometimes we see where we have to use the distributive property when there's just a negative in front. Anybody have an idea how we go about doing numbers? I don't. Very good. Put a 1 with it. So we have negative 1. And then what do you think we do from there? Very good. And then we just distribute. So I have negative 1 times 4 is negative 4. Negative 1 times that negative 2x would be positive 2x. You can think of this as, so we had negative 4 minus 2x. You can think of this as just distributing your negative. So now this becomes negative 4, and this now becomes positive 2x. You will arrive at the same answer. So you can think of it as distributing that negative. Questions on that? Okay. I want you to go ahead and do then on your own. I want you to try number 7, number 8, and let's go with number 5. I want you to do number 5, 7, and 8. Give you about 2 minutes to try that. Alright, so not negative 5. Number 5. Distribute my negative 2, and I get negative 2x minus 8. That's my final answer. Any questions on that one? If you had negative 2x plus negative 8, that is the same thing. That is fine. You had this. That is fine. And then number 7, we have to distribute my negative. So I have negative 6 plus 3x. That's my final answer there. Any questions on 7? Okay. And then number 8. This is the backwards one. So I have to distribute negative 9 times 1, which is negative 9. And negative 9 times the negative 2t. So negative times negative is going to give me positive. 9 times 2 is 18. And t times, there's no other t, so that's just t. So my answer here is negative 9 plus 18t. One's a little bit trickier. Alright, questions on that one? Alright, let's take a look at one of these problems. I love these types of problems because there's words and everyone groans at these. Alright, so we're going to take a look at number 10. It says, write and simplify an expression for the area and perimeter of the rectangle. I like to always read word problems just once to get an idea of what's going on, and then go back through and mark it and dissect it, see what we need to do. So write and simplify. Okay, so we're going to write down your answer. We do need to simplify, so that's important. Make sure we combine like terms. And expression is just simply what we've been doing here. An expression is just a combination of terms added and subtracted, multiplied, and divided together. For the area and perimeter of the rectangle. So we need to find area, which I'm going to call A, and we need to find the perimeter, which I'm going to call P. And they give us the rectangle here. Alright, so they give me my length, and they give me my width. And who remembers what the formula for area of a rectangle is? Go ahead, Joe. Right, length times width. So area is length times width. I'm going to call this one length and this one width. It doesn't matter if you flip-flop them because multiplication is commutative. That means that this is the same thing as width times length. So it's just the sides multiplied together. Okay? So for this particular rectangle, my area is, my length is x times my width. We have to be very careful when writing this because it's times the entire width, and the entire width is x minus 7. So you have to put parentheses around that because this entire thing here represents the width.
Remember, you're plugging in a value. Remember how every time we plug in the value, we come with parentheses? That's why. Because we need it.
We know that the width is x minus 7. Remember, is means equals. The width is equal to x minus 7. So all we're doing is substituting in x minus 7 for the width. Okay. Now, this is where simplified comes into play. This is not our final answer because it says simplify. That means we need to go ahead and multiply everything out. So looky here, I have to distribute. So x times x, which is x squared, and x times negative 7, alright? Same thing as 1x. So 1 times negative 7, negative 7. X, there's no other x with it, so it's just negative 7x. And this is my final answer here. So here's my formula for area for this particular rectangle. Alright, how do we find perimeter of a rectangle? Hey, Sean, do you remember? How to find perimeter? That's a good guess. We deal with height with triangles, though. So this is, with this being a rectangle, it's not quite it. Anybody remember what perimeter is? Alma?
Is it like you have to multiply all these sides?
That's very, very close. Not multiply, but Joe? Right. The perimeter is just the sum, meaning add, of all of our sides. Alright, so we have to add length plus width plus width. We have to add all of our sides together. Alright, well, the problem is they only gave us 2 sides. But, rules of rectangles, this side is the same length as this side. So that means that this is also x. And that means that over here is also x minus 7. Okay, so we just substitute these values in. So length, so we're going to just go around and add it together. So x plus x minus 7. Put that in parentheses. Plus x minus 7. Alright. Now we combine our like terms. Notice this is addition here, so I don't need to distribute it all. In fact, since this is adding, I don't need these parentheses. Still adding. Still adding this, so I don't need my parentheses. It's good to write in the parentheses, though, because had this been a subtraction sign in front, we would have had to distribute them. Okay. So then we go ahead and add these together, and I get 1, 2, 3, 4 x's, and negative 7 plus negative 7 equals negative 14. So my perimeter is equal to 4x minus 14. Any questions on that? Okay. So terms, like terms. Terms are the pieces that are multiplied together. Oh, sorry. Erase that. Erase the last 10 seconds from your memory. Alright, we are on the back side. Terms. The pieces that are added together. My apologies. That are added together. So what we're saying here is 2x plus 5y. 2x, that's a term, and we add that to 5y, which is a term. So this is a term, and this is a term. We add terms together. Right? But notice a term itself has that multiplication there. Alright, like terms. Terms that have the same variable. And we're going to do parenthesis s, because it might have more than one variable with it. With the same power. Alright, so for example, 2x and 3x. Those are like terms. We can add those together. So 2x plus 3x is 5x. 5x squared plus 3x squared. Same variable, same power. So we can add that together, that's 8x squared. Be careful. See how these are different variables? These are not like terms, so you can't add them together. It's left as 2x plus 5. So we've actually been adding, or we've been combining like terms all along, without formally calling it that. So it has to have the same variable, the same power, in order to be able to add it together. Alright, so I'm passing your homework out to you, worksheet number 12. Make sure you have this completed for your next class and come see us if you have questions.
You got lesson 4 on your quiz. You really need to say after. You only have like 2 more classes before the test.
No, you got a negative. You got a negative. No.
We'll trade it back. Did you trade your phone for calculator, or did you trade? You traded your phone or keys for a calculator, or is that?
Good.
Giovanna, is that right? Is this you?
I used to do that too, so.
Okay, so we have like terms are terms that have the same variables with the same power. And so like we said, you need to definitely make sure that you're looking at the power there. 2x and 3x both have just x, so that means that they do have like terms. But if I had 2x and let's say 3x squared, these are not like terms because even though the variable is the same, the power is different. So we actually cannot combine these together. We cannot simplify it anymore, and it's left as just 2x plus 3x squared. So do take note that you have to look at the power as well as the variable. Likewise, if I have 2x plus 3xy, this is close, but they're still not quite like terms. Because even though they both have x, they do not both have y. Only 3 has the y with it as well. So you have to look at everything that's after your coefficient. and whatever's after your coefficient has to be exactly the same. Here these are not the same, so again we could not combine them together. So let's take a look at an example in which you could combine things together. So let's say we have 2x squared plus 5xy minus 3xy plus 7x squared. Alright, so we have x squared and x squared, so we can combine these together. So I have a positive 2x and a positive 7, so I have positive 9x squared. Again, we just combine our coefficients together. Alright, and then we have, I like to do boxes and circles, so we have positive 5xy and negative 3xy. So 5 minus 3 is going to be 2xy. And again, notice, whatever is after the coefficients has to be exactly the same. Let's say that I tack on to the end plus 8x. I cannot combine that with my x squareds nor the xy because it's not exactly the same. So that would be something separate. Right. So let's take a look at just a couple examples, circling the like terms. So number 11, you see we have x squared, x, no variable, that's a possibility, and x. There are no other x squareds, so we have negative 5x squared. And if it helps, go and cross it off as you go through. Alright, then I have negative x and positive 6x. So negative 1 plus 6 is positive 5x. Took care of those. And then I have plus 8 by itself on the end. Again, I cannot combine my x squared and x because they do not have the same power. Alright, let's take a look at 15. I have 4, 2q, put a box around that because it's a different term. Negative 7qr, that's an even different one. Put a circle around that. And then plus q, that's the same as 2q, the same term. So those are like terms. Alright, so 4, I cannot combine that with anything else, so it's 4. And then I have 2q and positive 1q. So I can combine those together, and I get positive 3q. Cross those off. And then negative 7qr, nothing more I can do with that. Always check your answer to make sure there's nothing left that you can combine. And again, we cannot combine the q and the qr because these are not exactly the same. And we'll finish with number 16 because that's a doozy. Again, both the variable and the power have to be exactly the same. So I see 3xy. I'm going to look for any other xy. This is x cubed, so that's a different term. Negative 5xy, that's something. X squared, y squared, different power, so we can't do that. Xy squared, another power. Y cubed, again, powers, and x squared, y squared. Alright, so 3xy and negative 5xy. 3 minus 5 to be negative 2xy. So we took care of those. So now let's take a look at the next term we see. Positive 2x cubed y. So we need to look for anything else that has x cubed y. That doesn't work. That doesn't work. That's not the same. There's nothing else that has the same term, so then we have just plus 2x cubed y, and we've used that. Alright, let's take a look at what we have now. Positive x squared y squared. So we need to look for any other terms that have x squared y squared. This is close, but doesn't quite work because the x is not squared. This is not the same. This one we do have x squared y squared, so this is another one of our terms. Positive 2x squared y squared. So positive 1 plus positive 2 is positive 3x squared y squared. And we're taking care of those. Alright. So now we see we've got negative 8xy squared. Alright, well, we look, the only other term is y cubed, and that is not the same term, so we have negative 8xy squared. And then we have negative y cubed. There's nothing to combine that with. Look, we've crossed out all of our terms, so this is our final answer. Now, if when you went through, you maybe switched some of these around, so you might have had 2x cubed y before your negative 2xy, that's fine, as long as you have the proper terms combined together. Okay. So make sure when you're distributing that you also combine your like terms in the end, like we did with our perimeter problem here, how we combined our like terms within the perimeter.